It's everywhere, it's powerful, and yeah, it's one of our biggest hopes for a clean energy future. But there's a catch. This amazing potential comes with a hidden, super high-pressure problem that can lead to, well, catastrophic failure. Today, we're going to break down how one company tackled a massive challenge that stands between us and a hydrogen-powered world. Okay, so let's just dive right in. If hydrogen is such a game changer, why aren't we all driving hydrogen cars by now? Well, the answer is a huge engineering puzzle. How in the world do you control the lightest, most slippery element in the universe when it's under insane amounts of pressure? For one major chemical company, figuring this out wasn't just a thought experiment. It was a matter of survival for their entire operation. And this really gets us to the heart of the conflict. In the high-stakes world of chemical processing, hydrogen is kind of like a superhero with a dark side. Let's break down that dual nature to really get what the challenge was all about. On one hand, you've got the dream, right? A clean, powerful fuel that is literally the most abundant thing in the entire universe. But on the other hand, you have the nightmare. It's incredibly flammable. And even sneakier, it has this weird corrosive power, a way of weakening the very steel pipes that are supposed to contain it. So let's get specific. One of the leading chemical companies was living this nightmare every single day. Their whole operation depended on piping hydrogen around under these extreme conditions, and their equipment, it was starting to crumble from the inside out. I mean, just look at how intense these conditions were. We're talking pure hydrogen gas, heated up to 200 degrees Celsius. That's hot enough to seriously burn you in an instant, and pressurized to 100 bar. To put that in perspective, that's like having a small car pressing down on every single square inch. It is an unbelievably hostile environment for any piece of equipment. And the main enemy here is something called hydrogen embrittlement. What's so wild and honestly kind of terrifying is that the hydrogen atoms are so tiny, they can literally seep into the solid steel of the pipes. Once they're inside, they start messing with the metal's internal structure, turning it from something strong and flexible into something as brittle as a dry twig, just waiting to snap without any warning. And this embrittlement was causing a whole domino effect of failures. Their sensors were constantly breaking down. The few that did work were giving bogus readings because of the heat and pressure. And look, with a highly flammable gas like hydrogen, any failure is a massive safety risk. On top of all that, they couldn't just buy parts off the shelf. They needed custom connections for their unique setup. It was a total operational nightmare. So how do you fix a problem that complex? I mean, it's a super high-tech issue. The company needed a major breakthrough, and the one they found was, well, it was surprisingly elegant and, in a way, totally timeless. The answer? Gold. Yeah, really. Not some complex new alloy or a revolutionary new material, but one of the oldest and most precious metals known to humanity. More specifically, the solution came from a specialized pressure sensor. Its secret weapon was its diaphragm. That's the sensitive part that actually measures the pressure. This piece was custom plated with a layer of gold just over 20 micrometers thick. We're talking thinner than a single human hair. And this shows you exactly why it works so brilliantly. Think of the metal diaphragm like a wall. Those tiny little hydrogen atoms are like microscopic invaders trying to break through it. But that super thin layer of gold, it acts like a perfect, impenetrable shield. The way its atoms are packed is so dense that the hydrogen just can't get through. Simple as that. The metal stays strong, the sensor works perfectly, and the embrittlement problem is solved. Okay, that all sounds great in a lab, but did it actually work? Let's take a look at the real-world impact this one little change had on everything. First off, look at that number, 0.1%. The new sensors delivered pressure readings with that incredible level of accuracy. Now, in an industrial process, that kind of precision is the difference between wasting a ton of money and running at peak efficiency. It's literally the key to making everything work better. So in the end, this one single change had this huge positive ripple effect. Reliability shot through the roof, which meant way less downtime and fewer expensive repairs. The super accurate data meant they could fine-tune their whole process. And crucially, the new sensors were certified as explosion-proof, which gave everyone peace of mind when you're dealing with a gas as volatile as hydrogen. But this whole story is more than just a big win for one company. It actually holds a much bigger lesson about how we solve the engineering challenges of the future. This quote pretty much says it all. The solution wasn't just a band-aid. It became a core part of their strategy. It let the company operate at the absolute highest level, safely and with confidence. And really, that's the whole point of great engineering, right? To build tools so reliable, they just become part of the foundation of success. And that leaves us with one final thought. This whole massive problem was caused by something totally invisible, tiny atoms of hydrogen seeping into solid metal. And the solution was an equally invisible, microscopic layer of gold. It really makes you wonder, as we push into new frontiers of energy and technology, what other invisible barriers are just waiting for us? And what other elegant, brilliant innovations will help us break right through them?